Okay, so you got rules of logarithms, and the rules of logarithms are related to the rules of exponents because what are logs? Inverses of exponential functions, right? So you have this inverse relationship. Well, it makes sense that the laws of exponents would have inverse type relationships with the laws of logarithms. Okay? So we have this. Why is this? Because x to the a plus b is x to the a times x to the b. Okay? You have addition of exponents leads to multiplication. Okay? So you have a multiplication that leads to an addition. Okay? So the addition leads to multiplication, the multiplication leads to an addition. Okay? Or the addition leads to multiplication because the addition leads to multiplication. Okay? Now, working out the details of that, you know, back in the Stone Age when I was in high school, there were no computers. I mean, there were computers, but, you know, the time on a computer cost like $1,000 a second, and they were slow. Okay? So we didn't have computers, you know. So we had to use tables of logarithms to do big multiplications and divisions. Okay? Like if you want to divide two 6-digit numbers, you find their logarithms and subtract them and then convert that back to a number, which was way, way, way easier than doing the long division. Okay? And you could get everything accurate to about 4 significant figures, depending on how big a table you have. Much easier to do subtraction than a long division, right?
Yes.
Much easier to do an addition than a long multiplication. So we were able to convert multiplication and division and taking things to powers to simple arithmetic operations, simple arithmetic operations. Saved a lot of time. And everybody had big old tables of logs. Bigger your table of logs, the more accurate you could be. Okay? So we got really good with the properties of logarithms because we were using them every day. And I still had to ponder why this gave you this. I knew it did, but I'd have to, you know, I'd think it through repeatedly until it really made sense to me, right? You're probably not going to take the time, go through the mental anguish of totally understanding how this relationship and this are reciprocal relationships or inverse relationships, because logs and exponents, exponentials are inverse functions, okay? But that's why it is. And this can kind of help you remember this and also to remember what doesn't work, okay? We'll come back to that. The other I'm just debating about my symbols here because I think I use different symbols in your homework, but this is okay. Okay? We have this because x to the a raised to the b is x to the a times b. So you have raising to a power becomes an exponent, or becomes a multiplication of powers, and this is the equivalent statement to this. Okay? Now, all I want to do is get your feet wet on this. Ultimately, the thing that all this is good for is solving an equation like this. 2 to the 3x minus 7 equals 5 to the 4x plus 3. Okay? Now, you know how to solve an equation if it was 2 to the 3x minus 7 equals 9. Solve that easily, right? You just translate that to exponential form, and you get log base 2 of 9 equals 3x minus 7. And you just solve that. X is going to be 7 plus log base 2 of 9 divided by 3. You know how to do this. You did that on your test. Okay? And people did pretty well with this. So if you sort of got a little fuzzy on it, well, let me remind you. So this is easy. Whereas this is not as easy unless you have these rules. If you have these rules, then it becomes pretty easy. Okay? So that's kind of where we're heading. There's this one kind of logarithmic equation, and then there are exponential equations that you need rules like this in order to solve. Okay? But the rules are not that hard. You just got to not screw them up. Because you're going to have a tendency to write log of A plus log of B equals log of A plus B. Because it looks like a distributive law. It's not, there's no distributive law. Okay? So let me kind of make a big red note here. No distributive law for logs. Okay? Like the log of AB is not the log of A times the log of B. It's a log of A plus the log of B, right? And the log of A plus the log of B is not the log of A plus B, it's the log of A times B. Okay, so you got to get used to these laws, and if you do anything that doesn't obey one of these laws, you got to catch it. Which means you got to write out very explicitly what the law is and how you're applying it, okay? It's very easy to look at these and do what it looks like you think it ought to do, which isn't what it ought to do. Okay? It's even easy for people that know these laws very well, but they're in a hurry. Okay? People that have used them thousands of times, it's still easy to write it down wrong. Okay? I mean, I've never done it, but ordinary mortals do sometimes. Okay?